What's the average here? We haven't never took the average. You got to stick your hands into the table, do the dirty work, do the survey, knock on people's doors, get the data, do an experiment. You got to collect the data, which is summarized by the X bar. And if the X bar is in between, it's like an if statement. If this, then that. So for homework, I think the previous spinner assignment, I told you, now that we know the answer was 2 and 7, I said I think it was 6.2 we used in the homework, so spinner assignment 32 or 33. Well, what about 6? What was it, 6.2? Was that the number? 6.3. So 6.3 in between 2 and 7? Yes. So what's the answer? Accept A0. Do not reject A0. And basically that means the random number table, as far as we're concerned, is okay. End of story. But now I told the class for spinner assignment 35, I believe, to do it again, do everything exactly the same, but this time make the alpha 20%. And we'll talk about if Julie asked your question. Say again? This is the end of 32. I mean, you have to come up with a 2 and 7 as the end of it, but there are a lot of steps, remember a lot of iterations and trials till you get to that point. So that was today's homework. What about when it's equal to 20%? What do you change? Do you go back and do it by trial and error? Let's try 3 and 6. Let's try 1 and 8. Let's try 0 and 9. Let's try 4 and 5. We can do that all day long, and eventually we're going to get it right. Eventually we're going to pick a pair of numbers that is equal to 10% and 10%. But that will take us literally 20 minutes or more. So what's the shortcut that some of you realized? We talked about the shortcut last time, but it turns out there's a shortcut. I'll take the shortcut or the shortcut at this point, if anybody sees it. It's a shortcut we said last time already. And that's how you could have done the homework if you wanted to just do the whole thing in 2 or 3 minutes. Yes? Exactly. So what we said, we know this got to be 20%. That means this got to be what? 10% and 10%. So which number in the back of the book cuts off 10%? We did this last time. Minus 1.28. So then you take this equation and you make it equal to minus 1.28, because that's what we know the z-score has to be to satisfy our criterion. What's the unknown here? Is sigma of x bar unknown? No, it's 1.28. This happens to be a coincidence by doing this little formula. Is mu an unknown? No, it's 4.5. That's the hypothesis. Is the x bar the unknown? Yes, that's the boundary. That's the unknown we're looking for. So you can solve the equation and get your answer in 2 or 3 minutes if you know algebra. But that's where we're up to again last time, and I want to take it one step further to make it really easy for everybody, which is why it's shocking that people don't pick this up, because it really is very simple. The steps in mathematics are simple. The concepts are complicated. Anybody already see the shortcut that will take, instead of taking 3 minutes of solving this equation, will take you 30 seconds? What's the shortcut? No name? For you. I mean, that's why I guess hard to train you guys. When you pass it back to William King, right? Thank you. By the way, Julie, your suggestions last time were very good, a lot of those suggestions. Okay, so anybody see the shortcut? We don't have to solve the equation. Okay, I'll be glad to give it to you. That's what I'm being paid the big bucks for. The solution, which I'll first say it, then we'll do it, is to, I did say it at the end of the last class, I'm pretty sure, is you forget about all these pictures altogether. You forget about the trial and error, you forget about solving the equations. You basically tell yourself, I have my data. I know, again, for 20%, what should be the magic cutoff point? Minus 1.8 and positive. And anybody who hasn't looked up the z-table in the last few minutes, please do it, because you want to see where it comes from. But the 10%, when you look it up, comes out to minus 1.28. You then take your data, whatever the x bar happened to be, 6.3, 6.4, 2.8, whatever it is, convert it to a z-score. How do you convert anything to a z-score? We've been doing that since chapter 6 and chapter 7 and chapter 8 and chapter 9. You plug it into this formula. That converts the x bar to a z. You then say, is my z here? Is a small z, meaning the x bar and the mu are close to each other, so that basically they're consistent with the A0. Or in other simple terms, they're close to the middle value, which is do not reject A0. Or is the x bar far from the mu, in which case this will be a very positive number, or a very negative number if it's below the mu, in which case it's out here or out here. So that's it. That's 100% of the chapter of the test, except for a couple of verbal questions. Now that I said it verbally, let me just do it physically on the board. So I'm going to erase everything that we can erase And all the other stuff we're going to forget about. We don't need alphas anymore. I mean, we don't need the theory anymore. I mean, you need to know the theory in order to understand what you're doing and to do it right. You can't just guess the stuff. But we need this, we don't need this. We don't need this, we don't need this. All the stuff that we needed to do the example the long way is not really relevant anymore. We don't even need this whole picture. We do need this little formula. And okay, so when you do an example in Chapter 9 and Chapter 10, which all hypotheses, and likewise when you take Stat 2, all the subsequent chapters that do involve, almost all of them involve hypothesis testing, the problem boils down to 4 steps, every single problem. Now, some books say 3 steps, some books say 5 steps or 6 steps. I think 4 basic steps. You have to, at some point, specify the hypothesis. You got to know what you're testing. In this case, we're trying to test if the random number table is a good table or a bad table, which is mathematically symbolized by a 4.5 or not. So you need to write down and the basic structure stays the same in every example. All you got to really fill in is a single number, which is pretty easy most of the time. Then you take your data and convert it to a z-score. Now you can, okay, so now what's the data in this case? Well, you're going to do that right now in class. I'm going to ask you to do the Spinner Assignment 35 in class by the shortcut method. You're going to pick 5 numbers out of the back of the book, get the average, and you might get 4.8 or 4.4 or 6.2 or 3.6. You're going to get what every group or every person is going to get a different number. But whatever that number is, you're going to plug it into this formula here. What's the mu going to be? The mu is always the ideal number that comes out of the A0, which is 4.5. What is the sigma of x bar? It's equal to sigma over n. So instead of having 2 formulas, let's simplify our life a little bit and take this one formula and put it right here. Let's call this sigma over n. So we have everything in one spot. Sigma over the square root of n is the sigma of x bar. So it looks like a little different formula, but it's just moving everything over. So sigma is 287. The n is 5. This is 4.5. The thing that's going to be different from group to group is the actual 5 numbers and different x bar. So this is step number 2, coming up with a number. Step number 3 is you take the alpha that's given to you in every example. It's 5%, 10%, 1%. It changes from example to example. 5% is most traditional. You're going to chop it in half. Why are you going to chop it in half? Because there's a possibility of making a type 1 error when an x bar is too big by luck or when it's too small by luck. So you're going to look up 10% in the back of the z table, which we said before is minus 1.28. So I'm doing that for you now. But anybody who really wants to get this right should do this on their own. Make sure you realize that the boundary, in fact, is. So that's step number 3, coming up with that 1.28, the boundary. And finally, step number 4 is you take this number and you literally compare it to the boundary. Is it here? In which case you would say reject A0. Is it here? In which case you would say accept A0. Is it here? You say reject A0. That's it. And you got yourself, you do this twice. I think one example from Chapter 9, one from Chapter 10, and that is your test